All right, so let's talk about mass percentage, okay? And when we refer to mass percentage, we want to figure out the overall chemical makeup of a compound or molecule, okay? A good example that's used often will be something like calcium fluoride, okay? We have one calcium and one fluoride. So what we need to do is we need to go to our periodic table. There should be a periodic table near you, okay? So let's pick our periodic table out. So calcium, we're going to go in and round. For the most part of these videos, we're going to round. We will use significant digits and also rules concerning significant digits a little later. But for now, this is what we're going to set up with. So if we look at the overall atomic mass, okay, that should be the number either above, below. It's usually the largest number on your chart as far as your periodic table is concerned. So if we look at it, we can go ahead and start off. We know that calcium is going to be 40 grams per mole. Now keep in mind, I'm keeping nice whole numbers and just rounding. Okay, so if we do 40 grams per mole and we say fluorine, okay, fluorine is going to be 19 grams per mole. Okay, that's where we're going to start off with. Nice whole numbers. We can always put more significant digits, but this makes it a little bit easier for everyone. So I have 40 here and I have 19 here. What we want to identify is I have two fluorines here, right? So essentially I need to have this times 2. Okay, so we have 40 and we have 19 times 2. So it's going to be plus, and basically that should give me, if we want to use our calculator, we have 19 times 2, right? Gives us 38 plus 40, right? That gives us our 78, okay? So if we do that, we should get overall 78 grams per mole. Okay, hopefully everybody can see that. Now that is the molar mass of calcium fluoride. All right, so on to the next thing. What we want to do is I want to know what is the percentage of calcium in CaF2. Okay, calcium fluoride. Now, now we have our question, right? We have to break it down a little bit. So I know I have 40 grams per mole, right? As you already can see, we need to cancel out some units. So what we're going to do is, since I want to look at specific calcium, I'm going to put 40 at the top, okay? And then I want to put basically the total of calcium fluoride at the bottom. Now, normally we could say, okay, well, at the top I have grams per mole and I have grams per mole, right? Essentially, these will be crossing out anyway. So we're taking a percentage of calcium out of the total. So 40 divided by 78 times essentially 100%. Okay, what will that give us? That would give us 40 again divided by 78 gives us roughly 51%. Okay, so when we're looking at this, calcium consists of 51% of calcium fluoride. Okay, so that's how we can look at the percentages. Now, due to that this is 51%, we can assume that fluorine is going to be what? 49%, right? Now, how could we figure that out? Well, we can take it a step a little further, right? Keep going. If we look at fluorine, we know we have CaF2. We know that calcium is going to be the 40 grams per mole, like we saw earlier. We also know that fluorine is 19 grams per mole, right? So if we're looking at this and we know this is times 2, all right, so 19 times 2, that gives us a 38. So we know essentially it's going to be 38. Okay, this is representing fluorine. 38 divided by 78, right? And if we take it as this ratio times 100%, keeping in mind that, remember, the grams per mole crosses out, right? We should roughly get, if we do those calculations, roughly 49% if you round up. Okay, should be roughly 49%. Okay, which is in line with what we calculated earlier. So this is how we can check our work, and this is how we can figure out the percent composition of certain molecules, chemicals, or compounds. Okay, so if we take it a step further, right? What if, say, for example, I'm only given the percentages, right? What if I say, okay, I have calcium, which is going to be 51%, and I have fluorine that is going to be 49%, right? And I want to figure out the empirical formula, which the empirical formula is the lowest set of values that you can have for a chemical compound. So if we look at 51%, what we want to do is we want to assume that this 51% is out of 100 grams. Okay, this 51% is out of 100 grams. So this is going to be 51 grams of calcium. This is here, this fluorine is going to be 49 grams of fluorine, right? Now, what we have to take now is to convert it into mole ratios. Whenever you look at empirical formula, you can think of those as essentially mole ratios. So if I look at CH4, right, which is methane, if I have CH4, I have 4 hydrogen, right, per methane, or 4 hydrogen compared to 1 carbon. So these are still relatively what you could call mole ratios, right? So it's always looking at the lowest value possible when we're looking at the empirical formula. Keep note that when we're looking at the empirical formula, we usually like to apply this to non-metal-metal interactions. We can apply it to non-metal, but we lose some of the overall structure when we do that. And there are some other cases that we'll talk about when we're doing calculations concerning this. But for now, that's pretty good to start off of. So if we have 51 grams of calcium, right? Now, if I have 51 grams of calcium, what I need now is the overall atomic mass of calcium. And for calcium, remember, it was 40 grams per mole. So due to the fact that we want moles, because we're looking at mole ratios at this point, we want to make sure that the 40 grams at the bottom per 1 mole, this is say calcium, right? Over here, so these can cross out, right? And we'll see what that is. Then we have our next one, which is a little close here, but it should be fine. We have 49 grams of fluorine, and we know grams should be at the bottom. It's at the top. This is of fluorine. Knock this out, knock this out. So that gives me, using my calculator, if I do 51 divided by 40, that gives me 1.275. And if I do the 49 divided by 19, right? Divided by 19. That gives me 2.579. We'll keep it along the same lines of those. Right? So when I'm looking at this as far as ratios there, right? So what you want to do in the next step is essentially divide by the lowest factor. So when you divide by the lowest factor, you want to do this. You want to do 1.275, and you want to do 1.275. Okay, so this was the lowest value. This is where I'm going to divide it by. So essentially, we know that calcium in this case is going to be 1. We don't need to write it. It's already understood. But 2.579 divided by the, so 2.579 divided by 1.275. What we're left with. Now, technically, if we want to do multiplication rules, we should only have 2 significant digits. I'm shooting 11 more significant digits to help you out. So we have essentially 2.02, right? So over here, when we do this, we're not going to put 2.02, right? or even 2.0 if we break it down to significant digits. Because remember, I have 2 here, I have 2 here. Multiplication rule says take the least significant digit. In this case, it'd be 2 significant digits, but we can overall see that'd be CF2. Back to my original answer, okay? So you can go forwards and backwards. If you stick with this type of math, you should be fine.